Energy diagrams are an excellent way to integrate physics and biology concepts. And as I work with students as I work with faculty to develop things that we can do that are interdisciplinary across biology and physics, I find so many ways to use different versions of the energy diagram, and I create lots of different diagrams to share with other faculty, with students, and I often find myself saying, you can do anything with an energy diagram. Energy diagrams have been a great tool for me to use with my biology students. One of the things that energy diagrams achieve for me is they provide a model for me to help my students study biology. And some of the things that are important in biology education right now and our recommendations in biology education are having models, models that are both explanatory and predictive. I also in my long-term teaching career, noticed early on that students could learn to solve problems more easily than they could grapple with big concepts. And so that was sort of a surprise to me. I thought the problems would be challenging and the concepts would be easier. That was not the case. And so energy diagrams are a way for me to have a tool, among other tools, that can help me teach students how to learn conceptually so that they're not just memorizing, which tends to be a common approach for biology concepts, but that they have more depth of learning by looking at how biology concepts apply to physics through these visual diagrams that they can apply information to. So students are expected to create these energy diagrams themselves. So I will start by giving them some basic information, looking at some images, asking them some questions that are related to our textbook about the process, but then they have to figure out where the different energy compounds go. And so they're developing this. It's an active learning environment where they work in small groups and they identify the right sources of energy to go into the right areas of the diagram. They, of course, always have to isolate the system to show energy conservation and show all of the forms of energy that are in there. And then a really critical piece is to identify the times. So the times really can introduce or allow them to introduce what they're actually talking about. So if they are doing a very general overview energy diagram, they would say we start at the beginning where food enters into a cell, such as a muscle cell, and then we look at the end where the muscle cell has its usable energy in the form of ATP. Students being asked to develop this on their own and within groups is very collaborative, and it requires that students think critically and think together in order to create this new form of a diagram versus the types of diagrams that they're used to seeing from their previous experiences or that they are seeing through our textbook resources.